Psyche, a new 2022 mission to the Golden Asteroid. Space exploration has reached many records in recent years, from reaching Pluto with the New Horizons spacecraft, landing on a comet with Rosetta, and passing through the incredible close-up images of Jupiter taken by Juno. New missions, however, are in preparation. Among these, one of the most interesting is a NASA mission that intends to reach an out-of-the-ordinary celestial object, 16 Psyche. Not all asteroids are piles of rocky rubble like Bennu and Ryugu, the two objects recently visited by the OSIRIS-REx and Hayabusa 2 missions. Some are made of such sterner stuff, iron and nickel, the raw materials that concentrate at the dense, hidden center of worlds. These heavy metal members of our solar system are thought to be fragments from the cores of long-vanished orbs broken up by giant impacts, emissaries from otherwise inaccessible depths of time and space that lie billions of years in the past, or thousands of kilometers beneath the world's surface. Other than actually visiting such bizarre objects, there is no way to directly study these all-important building blocks of planets. This is why NASA is now working to send a probe to Psyche, the largest metallic asteroid around the Sun. By learning how Psyche formed, scientists may be able to explain the very hearts of other worlds, near and far, including our own familiar Earth. But perhaps NASA is also aiming for something more. We've already known for a long time the existence of 16 Psyche, which was in fact one of the first asteroids to be discovered, the 16th to be precise. And this incidentally explains the reason for that number that, as for all asteroids, precedes its name, starting from the first of all, or 1 Ceres, found in 1801. Those were the pioneering years of the Great Asteroid Hunt, which today can be counted in hundreds of thousands, both large and small, while in the 19th century they seemed really rare goods. The search technique consisted in meticulously recording stars up to the 14th magnitude, 10,000 times fainter than the faintest stars visible to the naked eye, present in a band in the sky centered on the plane of the ecliptic, where most of the asteroids of the main belt are concentrated. At that time, there was obviously no possibility to use photographic imaging. The plates were not yet sufficiently sensitive to light, so the research had to be done visually, measuring night after night any changes in the position of some of those dots of light. However, European astronomers took it as a race, and in 1802 was discovered Pallas, followed by Juno 1804, Vesta 1807, Hygeia 1849, Egeria 1850, etc. The 15th was Eunomia in 1851, until it came to the night of March 17, 1852, when the Italian astronomer Annibale de Gasparis of the Observatory of Naples, observing with a small telescope of 8.3 centimeters in diameter, measured a slow movement of one of those feeble lights. The calculations of the following days showed that it was an asteroid, the 16th of the series, which was then given the name of 16 Psyche, which traveled a fairly elliptical orbit at an average distance of 2.9 astronomical units from the Sun. Psyche, like the other planets, remained a mere speck of light for several decades, until astronomical instrumentation progressed to determine its size, mass, and other consequential parameters. To what we know today, Psyche is an irregularly shaped object with an average diameter of about 220 kilometers. An asteroid all in all normal at first glance. But then why is NASA preparing the launch of a probe that, after a journey of years, will orbit this small world? What is so interesting up there to deserve sending a mission costing more than $500 million? Simple. Size and mass data from a couple of decades ago led scientists to believe that more than 4.5 billion years ago, 16 Psyche was a protoplanet similar to the size of Mars. Involved in a series of violent impact with other large planetary bodies in what we now know as the asteroid belt between the Red Planet and Jupiter, 16 Psyche was destroyed. Its rocky mantle was torn apart, leaving exposed the core of iron and nickel. Further collisions heavily affected the metal layer and large fragments were thrown into space. All rocky planets, in fact, have a metal core, the result of the tumultuous period of formation of the solar system, in which the planets in formation, the heaviest elements, metals, were falling towards the center of the planet. Psyche would have all the credentials to be the heart of a planet now disappeared, or more likely, never completely formed. Immediately, the news was taken up by the media, which began to come out with articles where they spoke not of astronomy, but of money. Such a massive metal, they said, had to be worth at least 10,000 billion of billions of dollars, especially when new data began to lower the mass of Psyche to make the accounts of density, also began to talk about a large percentage of gold mixed with other metals. It was at that time that NASA thought to send a probe to check closely the real nature of that strange asteroid. But is there any truth in this story of the immense treasure that would hide Psyche? Well, maybe even if not in the terms proposed by the media. Okay, we know that the global electronics industry is an insatiable golem. Suffice it to say that to keep up with the production of new electronic devices, smartphones, electric cars, batteries, etc., 170,000 tons of rare earths are mined every year, with serious damage to the environment and people. And we also know that having China almost a complete monopoly on the production of these resources is producing significant friction in the geopolitical field. If Psyche really contains metals useful for the Earth industry, iron and nickel aside, then it will be possible to find inside it gold, platinum, neodymium, cobalt, and other rare earth metals for an estimated value of trillions of dollars. A mineral wealth that could accelerate the nascent space mining industry. For now, only a little more than ideas and graphics, but nothing concrete. And NASA's mission could be the start of a radical change. Maybe. There's in fact actually a more fundamental reason why a giant golden asteroid wouldn't make the world fabulously rich. It's because wealth mostly doesn't come from big hunks of metal. It comes from the ability to create things that satisfy human desires. A steel factory represents real wealth because you can use it to make parts for cars, buildings, and so on. A house does too because you can live in it or rent it out. The skills and knowledge in your head are also a form of wealth, even though they're not counted in the official statistics. Even a sandwich is wealth, at least until it goes bad. But a giant asteroid full of gold only adds a little to real wealth. The metal would have various industrial applications and make nice jewelry and dental fillings, but it wouldn't spark a new industrial revolution, or dramatically bring down the cost of goods and services, or in general make human life much better or more comfortable. Hang on a sec before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you will help us to make products of even higher quality. Gold doesn't command high prices just because it's rare. Plenty of rare things have little to no market value. It's because it's rare relative to people's demand for it. And because a golden asteroid wouldn't increase the world's total demand for gold, there's no way it could create quadrillions of dollars of new real wealth. Something a bit like a golden asteroid happened once before. In about 1500, Spain conquered South and Central America and discovered large deposits of gold and silver. It then shipped these metals back to Europe and used them to pay for government expenditures, mostly wars. Because gold and silver were used for money at that time, a drop in the value of gold and silver meant a drop in the value of money, in other words, inflation. Gold is no longer used as money, nor is the value of modern money pegged to the value of gold or any other metal. Thus, the arrival of a giant golden asteroid would probably not cause consumer prices to go up, and would instead simply cause gold prices to crash to almost zero. Be that as it may, new studies have partly scaled back the amount of metal present on Psyche, bringing its average density to a value of 4 grams per cubic centimeter, higher than any other metallic asteroids, but low enough to cast doubt on the exposed core theory. This means that if Psyche is all metal, it must be extremely porous. Another possibility is that, despite its metallic surface, Psyche is still holding on to at least some of its lighter, rocky mantle. But if that's the case, why does its surface look so core-like? In short, there is still a lot of confusion around. The hypotheses overlap and astronomers have the most different opinions. To give an answer to this and other questions, but also, needless to deny it, to begin to explore the possibility of exploiting the asteroids from a mining point of view, on August 2nd of next year will be launched precisely the Psyche mission, which will start from the Launch Tower 39A of the Kennedy Space Center on board a Falcon Heavy of SpaceX. The probe that will analyze Psyche will be about as large as a tennis court, including solar panels totally deployed. Just the solar panels will have the task of supplying energy to all onboard systems, including thrusters, navigation, and scientific instruments and communications. For this reason, their surface is very large. The central body of the shuttle, in fact, is only as large as a small car. This mission will use a Hall effect thruster utilizing solar electric propulsion, where electricity generated from solar panels is transmitted to an electric rather than chemically powered rocket engine. Psyche will be the first mission to use Hall effect thrusters beyond lunar orbit. The Psyche spacecraft will carry on board several scientific instruments, including a gamma-ray and neutron spectrometer, to map and analyze the chemical composition of the metallic asteroid. It will also be able to verify and measure the magnetic field thanks to the magnetometer mounted on board, and obviously provide high-resolution images using the two multispectral imagers. Taking advantage of solar electric propulsion and a flyby with Mars in 2023, the probe will reach the asteroid in January of 2026. Once there, the satellite will orbit 16 Psyche for 20 months, conducting its operations from orbits closer and closer to the surface. Its first regime, Orbit A, will see the spacecraft enter a 700-kilometer orbit for magnetic field characterization and preliminary mapping for 56 days. It will then descend to Orbit B, set at 290-kilometer altitude for 76 days, for topography and magnetic field characterization. It will then descend to Orbit C at 170-kilometer altitude for 100 days to perform gravity investigations and continue magnetic field observations. The goals of the mission are clearly intuitable from what we have said so far. They are to understand in depth the role of iron nuclei in the formation of planets. By examining the characteristics of the asteroid, it will be possible to discover similarities and differences with the Earth and with the terrestrial planets. Moreover, it will be possible to explore for the first time a celestial object with these very special characteristics. From the scientific point of view, researchers have several needs to meet on this interesting asteroid. They want to determine whether it is a planetary core or an asteroid composed of unmelted material. They want to determine the relative ages of the various regions of its surface, whether the small metallic bodies incorporate the same light elements as are believed to be present in the high-pressure molten metal core of the Earth. Finally, they intend to characterize its topography. After 20 or 21 months, except for an extension of the mission, the spacecraft will be left in orbit around Psyche like a small moon, on an orbit that will preserve it from impact with the asteroid for at least 20 years, and probably for decades to come. Will this be the beginning of the mining exploitation of the asteroid belt? What do you guys think?